Hello everyone, my name is Jack Dowling and welcome to my science channel. The goal of this channel is to strive to help you learn more about science and better understand the world that we live in. The first topic I'm going to cover on this channel is the topic of space. Now I know what you're thinking, how is he going to cover space? It's so large, it's vast, and we don't know everything about it. Well, you'd be right. But I hope to cover this series in a series of smaller sub-series that will help you gain a better understanding of not only the world, but also the universe that we live in. So, what's the first topic? The first topic that I'll be covering in this space series is the topic of planets, specifically planet formation in the protoplanetary disk. Now that sounds like a mouthful, and it seems like we already know a lot about planets. I mean, we live in the solar system, we have 7 other planets around Earth that we know about, and we seem to be finding more planets each year. While we do know a lot about planets, it's important to gain an understanding of these planets in order to determine maybe where human life can exist one day and how we get there. Now let's start at the beginning. It may not be where you think. In order to form a planet, you must first have one very specific thing, a supernova. Now, what is a supernova? Essentially, a supernova is when a nearby star gets so massive and so big that it runs out of all of its fuel and implodes on itself. This implosion causes a massive explosion, which releases molecules and elements into the space around it. Now this is very important for planet formation. These molecules form a molecular cloud, and over time, molecules begin to form together and make clumps of molecules in this molecular cloud. As these clumps of molecules are being made, they gain gravity, which causes more molecules to fall into the center of them. Now, I know what you're thinking, why is this important? It's actually very important for one specific reason. It's very important for the formation of a star. So, when these molecules are falling into the center, they release energy into the center, and over time, as this clump of molecules builds up, it begins to burn. In fact, it begins to fuse hydrogen together, and that is when you know you have a star. But, in this process, another thing is also occurring. The molecular cloud, the molecules in it, begin to collapse down into a disk and rotate around this star. Now this may seem familiar when you think about an orbit, but we'll get to that later. So this disk is rotating around the star, and the star is getting hotter and hotter as more molecules fall into it. So once the star is hot enough, only the materials that are close to the star are ones that have very high melting points. These are called refractory materials, refractory elements. They are ones that do not vaporize when in situations of extreme heat. Now, further out, you'll get more dust molecules, more molecules that we call volatile. Now, volatile molecules are molecules that are opposite of refractory. They melt easily, they vaporize easily, and you won't get a lot of those close to the star. Now, this may seem like extra information, but it's very important to how planets form, and I'll discuss more about this in the next video.